So we're going to start looking at our investigation where we're given this situation. A woman named Manisha starts her exercise routine by jogging to the gym. Her trainer says this activity burns 215 calories. Then her workout at the gym is to pedal a stationary bike. And this activity burns 3.8 calories per minute. So I just underlined kind of the key points in here, the points that we're going to use throughout the investigation. So our first step tells us to write a recursive rule to generate the total number of calories burned after each minute of pedaling. So I want you to remember the two parts of a recursive rule. The two parts of a recursive rule. First one being, we need to have a starting point. And then the second piece is the rule which tells us how to move from term to term. Rule which tells us how to move from term to term. So in this example, we're looking at how many calories she's going to burn at her workout after each minute of pedaling. So let's think about her starting point. How many calories has she burned right when she first gets on her bike? It tells us up here that she runs to the gym, she jogs to the gym, and she burns 215 calories by doing that. So right from the get-go, she has burned 215 calories. So that's my starting point. And then, how am I going to move from term to term? How am I going to move from this, her starting point, to how many calories she's burned after 1 minute, 2 minutes, 3 minutes, and so on? And what I'm going to do is I see that she's burning 3.8 calories per minute. That means for every minute that she is pedaling on her bike, she burns another 3.8 calories. So I start at 215 calories, and then for every minute, she pedals, add 3.8 calories. And there's our recursive rule. So now what we're going to do is we're going to create an input-output table. So the input-output table uses this recursive rule to determine how many calories she's burned after each minute. For right now, we're just going to look at this column and this column. We'll not use the second column for a few minutes. So after 0 minutes, so right when she first gets on the bike, before she even starts working out, we've already decided that that starting point is going to be 215 calories. And now what I can do is I'll use my calculator. Not there. So after 1 minute, move this over. So after 1 minute, she just starts at the 215, okay? And then after 1 minute, we just add 3.8 calories. So we do plus 3.8, and I hit enter. So that's going to give me the calories burned after 1 minute, 218.8. Now, if I just keep hitting the enter button, it's going to keep adding 3.8. So after 2 minutes, I'm at 222.6. This would tell me how much at 3 minutes, 4 minutes, 5 minutes, 6 minutes, and so on. So our table asks us to fill out all the way up to 60 minutes. I don't know about you, but it seems like kind of a lot of work to just keep hitting this button until I figure out how many calories she's burned after 60 minutes. So what we're going to do is we're going to move on to step 3, where we write an algebraic equation. And then we can use that equation to determine how many calories she's burned at any point in time. So let's read through this. Let X represent the pedaling time in minutes, and let Y represent the total number of calories burned. Write an algebraic equation representing the total number of calories burned for any given time. So what we're looking to calculate is the total number of calories burned. And it tells us here that should be represented by Y. So I'm going to set this equation equal to Y. I'm going to say Y equals, and then I have 2 pieces of the equation that I want to put here. And those 2 pieces are going to relate back to this recursive rule. So the first piece I'm going to put in is my starting point. I'm going to put in 215 because that's where she's starting. So before she rides her bike, if she rides for 0 minutes, the total calories burned is going to be 215. But then for every minute she rides, she's going to burn another 3.8 calories. So what I'm going to need to do is add in a variable here so that I can plug in how long she's been pedaling for to find the total number. So my variable is going to be X because X represents the pedaling time in minutes. So there we go. We've got our equation. Y equals 215 plus 3.8x. Now let's go back and we're going to finish filling out this table. So I'm going to write my equation right here. It's again Y equals 215 plus 3.8x. Now what I can do, and this is why it's called an input-output table, I'm going to take the numbers that are in this input column and plug them into my equation, which will produce my output, the amount of calories burned. So let's just do it for the ones that we've already done. And rather than just using the calculator like we did before, we'll use this equation to find their answer. So I take my 0 is X, and I'm going to plug that into my equation. So I get Y equals 215 plus 3.8 times 0. Now I know 3.8 times 0 is 0. So this simplifies to 215 plus 0, which equals 215. Let's do the next one. Y equals 215 plus 3.8 times 1. And that equals 215 plus 3.8 times 1 gives me 3.8. So I get 218.8. Next one, Y equals 215 plus 3.8 times 2 equals 215 plus 3.8 times 2, which gives me 7.6. And so the answer is 222.6. Now let's give it a try with X equal to 20. Again, I've just plugged that right into my original equation. Y equals 215 plus 3.8 times 20. And that equals 215 plus 3.8 times 20. Gives me 291. I want you guys to do the last 3. And then at the end, I'm going to have you take a picture of this and send in your table. Now we'll plug in 30 for X. So I get Y equals 215 plus 3.8 times 30 equals 215 plus 3.8. I'll put in my parentheses, 3.8 times 30 which equals 329. And then I enter in 45 for x, y equals 215 plus 3.8 times 45 equals 386. And then last one, y equals 215 plus 3.8 times 60 equals 443. So these are the total number of calories that she's burned after 60 minutes of pedaling, along with her jog on her way to the gym. Now what we want to do is we're going to enter in those values from the table into our calculator, and then enter in our graph into the calculator, and make sure that the graph passes through all of our points. So you guys can use your TI-84 calculator on your Chromebooks to follow along. It should look pretty much the same. So what I'm going to do is I'm going to go to Stat, and I'm going to hit number 4, Clear List. And I want to clear list number 1 because I had some values in there. Hit Enter, and that's done. Now I can go to Second List. Oops, no, that's not what I wanted to do. Second Quit. I go to Stat, and I hit Edit, number 1. And I have my list 1. So I'm going to list all the values in my input column. And then I'll go over to list 2, and I enter in all my output values. Okay. So from this screen, I'm going to go to Second and then Stat Plot, and I'll hit number 1. And I want to make sure that this is on, Plot 1 is on. We want to have it on this first one, the scatter plot. And we want to make sure our X list says list 1 and our Y list says list 2. If you need to change that for some reason, if there's nothing there, you need to hit Second and then list 1 and then Second list 2. And let's go to our graph and make sure it's showing up. The other next piece that we need to do is hit Window. We hit Window, and we need to make sure that our window will capture all of these different points. So I'm going to set my window to -5, so I know it's less than the smallest x value. And I'm going to set it to go all the way to 75, which is bigger than my biggest y value. And I'm going to have my scale count by 5s. And then for calories burned, I'm going to have the minimum be 0 and the maximum be 500. And then I'm going to make my y scale, I'm going to have it count by 25. And then I'm going to hit graph. Aha, and all my points will show up just like that. Now, let's go in. We hit y equals, and we are going to enter in our equation that we came up with. So that's 215 plus 3.8x. And then go back to the graph, and we see that the line goes through all of those different points. So we just took care of step 4. We see how the points on our table match up with the points plotted by our equation. And now I want you to take a look at step 5. How does the starting value and the recursive rule from step 1 show up in our equation? And just kind of quickly, I want to hint at something that we're going to talk about a little bit more in a second, which is the intercept form, y equals a plus bx, where a is our y-intercept and b is our slope. We talked about this a little bit when we were looking at the problem of the 3 different cars driving in Michigan. So when we think about that, take a look at the equation. Take a look at our recursive rule. And I'm going to have you submit an answer for this in Google Classroom. How does a starting value in the recursive rule from step 1 show up in your equation?